Okay, I wanted to make a video on the Reteach worksheet that I gave you. Again, you do this worksheet, I'll give you a code to redo the test. So just make sure you're learning this, and please ask any questions you have. So the first area is this heating curve, and the questions ask you what's going on. So from A to B, you're warming the solid. Whenever there's a rise, you're getting a temperature change. From B to C, the solid is melting. From C to D, the liquid is warming. From D to E, the liquid is boiling. And from E and beyond, then the vapor is warming. The temperature is going up on the vapor. The next question, it says going from A to E, is that endothermic or exothermic? It's endothermic. You must add heat. Now, if we're going from E to A, it'd be exothermic because heat is being released. The next question is, where is kinetic energy at the lowest? Well, that would be at A. Remember, a solid has a definite shape, definite volume. The molecules are very close to one another, so that would be the answer for the lowest kinetic energy. And then I gave you a data table, and I said use it to find which compound is represented. Well, if you look on your graph, I didn't put the numbers here, but they match up to rhenium. Okay, obviously I made up some names there, but there you have it. Okay, on the second page then, I wanted to go ahead and give you some problems. So in number 1, Q equals mH of F. You have 25 grams. Heat of fusion for water, we're talking for ice, we're talking about that, and it's 334. I'm not going to write all these down. I gave you a data table on this to have that available for you. It's 8,350 joules. For number 2, you have something that's heating, so it's Q equals mc delta T. When you have a temperature change is when you use delta T. This is water. So we have 250 grams. So that's water is 4.184 joules gram degrees Celsius. And the temperature change is 65 degrees Celsius. That's a 5. Sorry about that. And that answer is 68,000 joules, or 68.0 kilojoules, keeping it to 3 significant digits. On number 3, Q equals mH of V, and you have 75 grams, and you're looking with aluminum, and you'll see that I gave you the data table up there is 10,530 joules per gram. I'm not doing a good job canceling units for you. Sorry about that. And your answer then for number 3 is 790,000 joules, or 790 kilojoules. For number 4, didn't mean to be too gross with you on this one, but it's just realism. Try to give you as many realistic problems as I can. So 350 grams of water, and it's 2,260 joules per gram. And so 791,000 joules, or 791 kilojoules. Okay, I'm going to flip over to the other side and try to squeeze these in for you. Okay, so on number 5, it's Q equals mH of F, and you get 275 grams, and you get 334 joules per gram, and that ends up then equaling 91,800 joules, or 91,900 joules is also correct. it's worked out in terms of significant digits. Okay, on number 6, Q equals MC delta T. And I'm going to bring this down a little bit so you can see it better on the video here. 2 times 10 to the 3rd grams. The C, this is aluminum, so 0.897 joules gram degrees Celsius. And the temperature change is 12 degrees Celsius. And so your answer is 21,500 joules. For number 7, again, a Q equals MC delta T. We have a temperature change. That's why we use that. And so you have 1,250 grams. C is water, so 4.184 joule per gram degrees Celsius. And the temperature change is 40 degrees Celsius. And your answer is 209,000 joules, or 209 kilojoules. And finally, for number 8, that's another Q equals MC delta T. You get 355 grams. It's water, so 4.184 joules per gram degrees Celsius, and the temperature change is 23 degrees Celsius, and your answer is 34,200 joules, or 34.2 kilojoules. I just put kilojoules there because to me it makes it a smaller number. You're welcome to leave it in joules. And so I hope that helps, and I hope you're able to do real well on the retest.